Hey, what's going on, guys? This is Ivan Yosifov, and welcome to another Pygame tutorial. We'll be creating a fun little game called Eat Healthy. Let me show you what it's all about. So when we start the game, we'll have this initial screen where we have the instructions for the game, and pretty much what we need to do in the game is try to catch the healthy food and avoid the junk food. And in the beginning we can select our player. There's a boy and a girl. So if I select the boy, we can move it by using the mouse, the arrow keys, and every time I catch a healthy food, the score increases by 1, and every time I catch a junk food, the score decreases by 0.5. And also, if I miss a healthy food, I lose a life. So when the strawberry goes there and the apple, the game will end. So when we lose our lives, it will print the score, the final score. And also, if you want to play again, we can press spacebar. So if I choose the girl now, so again we're trying to catch the healthy food and avoid the bad one, and we don't want to miss like healthy foods. So if I start missing healthy foods, my lives down there decrease. And pretty much this will be the game we'll be creating. The good thing about this game is that we're gonna create this game using object-oriented programming. So for the player and also for the food items, like the food items, we'll have separate classes, and also we'll have a class for the game. The class for the game will take care of the scoring system, the collision system, and a few other things. It's nothing complex. It's nothing to worry about. Okay, so let's go ahead and get started. Now, before we start, I'm gonna create a folder on the desktop as usual, and I'll call it game. Now inside of this folder I'll create a couple of folders for fonts, for the sounds, images, and yeah, these are the resources we'll be using. And also we'll have a file for the game. I'll call it main.py. So this is where we'll be writing the logic for the game. So let me get the resources. For the font I'll be using this pumpkin soup. And I need just this one, pumpkin soup.ttf. The rest is I don't need it. So then for the background image I'll be using this this image of I think it's a tabletop with some vegetables around, and the links for all the resources will be in the description of the video. Also, if you don't want to download them separately, I also have a GitHub link for the whole game where you can download them as a zip file, all of them. Okay, so I'll download this one. and I'll call it just table. This will be the background image again. Now this image is kind of light, and I want it to be darker because otherwise the contrast between the background image and the foot images will be very low. So I will darken it, and also I will scale it a little bit. So I'll scale it by 900 by 596. You can use whatever dimension you want, it really doesn't matter. And then I will darken it. Maybe 50. And there we have the image. It's this is the background image. Next thing I want to do, I want to have the select the player images, and I'll be using this boy image, and I will download the 128 by 128 pixels. And I'll just call it boy. And I'll do the same for the girl image. Now, for the foot images, I'm not going to be downloading all of them because there are a lot of them. I have pre-downloaded them all, and I've put them in two folders, like healthy and junk. So when we are generating the food items, we'll be randomly getting either from the healthy folder or from the junk folder. And here I have 13 items, and they're all downloaded from here. So as you see, there are a lot of food stuff. So here the berries, the lettuce, the carrot, they all come from here, and they're all 64 by 64. And the same thing applies for the junk food. Like we have different sorts of junk food. They're all again 64 by 64, and they're from here. Now again, I'm not going to be downloading them all because it will take a while, but all of these, they will be provided as a zip file for download in the description, and also actually not in the description but on my GitHub page. But the link for where you can download them or find your own images from here, findicons.com, and when you search for food, there are like a lot of them. Okay, and then for the background music, we'll be using this one. From bensound.com. And I'll call it BG Music, and I'll put it in the sounds folder. And for the eating sound, I'll be using this sound. It's like a crunch sound. And again, you can download here from free sound. You just need to be logged in. And I'll call it eat. Okay, so these are all the resources we need. So let me open that file in the Mu editor. Okay, sorry about that. Just a second, guys. Okay, so I will load this file. Now actually, before we start writing code, if you do not have Pygame installed, it's a module, you need to either use pip install Pygame, or if you're using the MIUI editor, you can click the cogwheel here, go to third-party packages, and write Pygame, click OK, and it will behind the scene do a pip install Pygame. Or you can just use the command line and install it. So once we have Pygame installed, first of all we need to import it. And we'll also be using two more modules that are part of the Python language. The first one is random, and the other one is OS. We'll be using this module to read the file names from the healthy folder and from the junk folder. So we're not going to be loading these images separately. We'll just read the names and then generate the image on the fly. You'll see it a little bit later how we do this. Okay. Now the next thing we need to do is we need to set our screen. Actually, initialize Pygame. And here we'll be writing the logic for the game. Now the width of the screen will be 900 by 596 because I'm following the background image, this table image, which is 900 by 596. That's why I'm using these dimensions. So because I want the whole image to show on the screen. And then we need to create the screen. Here on this line we are setting the caption. This will be the caption of the game up on the top here. Now in this game we'll have animations. You know, the food items will be moving. We'll also be moving the player. So we need to set the FPS or frames per count, and I'll set them as 60. And in order to control that we get exactly 60 frames per second, we need to create a clock variable. Okay, we'll also be using a couple of colors. And in Pygame we define colors using a tuple with 3 values. Each value represents, the first one is the red, green and blue. So black is absence of all colors. And we also use a couple of other colors. So these are the colors we'll be using for the text. Okay, then we need to create our game loop. And the game loop will be an infinite loop. And inside of this game loop, we need to have the event loop. The event loop will be taking care of listening for events that are happening inside of the game screen, like closing the screen or pressing keyboard key presses, or when we're interacting with the mouse. So in order to set up the event loop, we do it like this. Now this is the event loop, and the first event we'll be listening is for the closing of the game. Now when we start the game, there will be this close button up top, and we need to listen if the user presses this button. So if the event type is equal to pygame.quit, that means when the user presses this close button, we will stop this infinite loop and we will execute this command pygame.quit, which will close the program. So if I run this program right now, so here's our window, here's the caption up top, and this close button corresponds to this event, the Pygame quit event. So when I click it, running through. Okay, let me just set the Pygame display update and tick the clock. So that's weird. For event in Pygame. Oh, sorry about this, guys. This is false. So when we quit the game, we set the running equals to false. This will exit the while loop and it will execute the quit command. So when I click it now, it will close. And another thing that we do inside of the while loop, besides the event loop, is we need to update the display. So every time this thing is running, we want to update the display, which means we want to show the new changes. Like currently nothing is happening on the screen, so we don't see any action. But a little bit later, when we start controlling the player, we'll be seeing that this update command will take care of like updating the screen on each frame and show the new changes. And the last thing we do is like we call the clock variable and we actually tick it, passing the FPS variable. And this line takes care that this while loop is executed 60 times per second. If we set the FPS to 10, the while loop will be running 10 times per second. But because we have some animations, we wanna have like 60 frames so that it is smooth. It looks smooth. Okay. Next thing I wanna do is I wanna show the background image. Now with this command we load any image, and when we load the image, another good thing to do is to make a rectangle around the image so that we can better position it. Now for this image, I'll create a rectangle around it. And when we call getRect, this will create a rectangle around the image, and then we want to get specific points or specific coordinates on that image. So I wanna get the top left, and here we pass the X and the Y value. So what we are doing here is we are creating a rectangle around the image, and we're saying that the reference point for this image, whenever we're addressing its coordinates, will be the top left. So top left will be up here. So 0, 0, get the image from the top left, and then we can show this this background image. And this is not BG, this is stable. So here's the background image, and we said that the top left coordinate will be 0, 0. So get the top left of the image and position it over here. Here we can pass other parameters like center, where we get the center of the image, and then if we position it here in the center, let me show you. So this is the center of the image. So here's this tomato. So from the center, position it in the top left coordinate here. Okay, but we don't want that. We want to start from we want to get the whole image. Okay, so this is working. Now another thing we need to know is that we're not gonna be doing a lot of stuff inside of the game loop, because we want to be using classes, and our classes will be doing the heavy lifting. So here we're not going to be doing this thing. We'll be using a game class that will be showing the respective screen, and you'll see what I mean in a minute. Now the first thing I want to do is I want to create my player class. So I'll actually declare my classes up top, and we'll have three classes: a player class, food item class, and a game class. Now, because the player class will be showing an image, we need to make it so that it extends the sprite class. That means that the player class will be inheriting from the sprite class, and the sprite class is given to us from Pygame. Now, so here we're creating a regular class, but we want to inherit from the Pygame sprite class. So when we do this thing, we get all the functionality that comes from the sprite class. And actually we need to declare this, we need to get that functionality from the constructor. So the constructor for the player class needs to call the constructor of the sprite class in here, so that we can get the functionality from the sprite class. So in this line, this super refers to the sprite class, and we are calling the constructor of the sprite class. And here we get all the methods that are part of the sprite class, and you'll see that in a minute. Now, when we're creating a player class, in the beginning we'll have to know whether the user chose the boy or the girl image. So if they choose the boy image, we need to get the boy image, and if they choose the girl, we need to get the girl image. So when we're calling the player class, we need to pass also the type of the player. Is it the boy or is it the girl? So here we'll pass the self, and this is for each methods that we declare in the class, we need to pass this the first parameter, self. Self refers to the player class, and then we pass the things that we need. So here I need the type. And then we need to check what kind of type that we pass. So this type will be either boy or a girl. It will be a string. And then we need to load the image of the boy. And it's a good thing to pass also this thing convert alpha. It's just a good practice, and I also actually do this also for the background image. You need to you need to add this convert alpha so that the image will load faster. And let me just check, yeah, they're PNGs. Okay. So now that we have this image, we need to set it. So we're creating a image variable class. I'm not exactly sure how they're called, but when we call it as self.image, means that all of the class will have access to this variable. Now this image variable that we created here will be can be only accessed from the init method, but a little bit later down in other methods we'll be using this image variable. So we need to make it self-image and refer it to the image, and this self-image we can use it in other methods inside of that class, while this is only contained inside of that method. Now, since we have an image, we want to have a rectangle around this image. And for this image, I'll get the mid left coordinate, because when we start the game I want this image to start in the center, at the left in the center. So if this is the left side of the game, I want it to be right here in the center of the screen. And window height will be divided by 2. So window height, the middle of the window height will be like, what was that? 596 divided by 2. Okay. Now, how fast we move the image will be controlled by the velocity, self-velocity variable, and the bigger value you give here, the faster you'll move the image on the screen. And I think 10 is kind of okay, but we'll try it a little bit later. And the last thing we want, and actually let's see if this thing works, like before we start writing a little bit more. So I'm gonna create a player image here, just call it P, and I'll call it boy. And so P image refers to that self image, and P rect refers to the rectangle around this image. So with P image we're calling the self image, and with P rect we're calling the self rect, this rectangle. So let's see if that will work. And here we have the image of the boy. Now this is a little bit too much, so I wanna like scale it down, because this right now is 126, I believe, by 126. Yeah, 128 by 128, and it's a little bit too much. So I will scale it maybe here, or actually before we add it to the self image. Now the Pygame transform smooth scale accepts two parameters. It accepts the image that we want to scale, and inside of these coordinates the width and the height. So I'll make it 96. Actually, let me see. If we make it, for example, 64 by 64 and run it, you'll see the image is very small here. So I want it to be 96 by 96, and there we have it. Now there are also other functions that we can use to scale the image, but I believe there is one called just scale. But if you use this one, you'll see how it gets jagged, so it doesn't scale very well. It doesn't scale down very well. So when we use smooth scale, you see the image looks like crisp. It doesn't have these jagged edges around it. Okay, so this thing is working. Now another thing we want to do is we want to add the ability to move the player. We want to have a function that moves the player. Now this function will not accept any parameters. And in order to move the players, we'll be moving it on the vertical axis, so just up and down. And what we're gonna do is we'll add the ability to move the player either using the arrow keys or the W and S keys, because these are the most standard keys that we usually use to interact with when there's movement. So in order to get the keys that are currently pressed, we create a keys variable and we set it equal to Pygame key get pressed, and this will get all the keys that are currently pressed. And this keys variable is actually an array, and we can find out which keys are pressed here. So in order to check for if the W key is pressed, we use this one, key K underscore W, and this applies both to lowercase and uppercase. So it doesn't matter if you press upper W or lower W, this will fire. Now if the W is pressed, or we also want to check if the up arrow key is pressed. And this is for the up arrow key, K underscore up with capital UNP. So if this thing is pressed, we want to move the rectangle of the image that we have around the image on the X coordinate. So when I press the image, I want this, when I press W or up arrow, I want this image to move up. So when we're moving up and down, we are working with the Y axis. So the Y axis, it starts from here, and if we are moving down, we are increasing the Y axis, and if we are moving up, we're decreasing the Y axis. So here I will take the Y and I will decrease the self velocity. So every time I press one of these keys, the player will move up 10 pixels. Now I'm going to do the same thing for the other keys. We can just do L if. So S is for the S key. And as you probably guess it, K down is for the down arrow key. So when we're moving the player, we are calling we're listening for these events, and the player should be moving. Now the last thing we need to do is we need to call this function so that we can see if this thing is working. So I know I'm writing in here, but a little bit later we'll see we'll be using the game class that will handle all this logic. So we're not gonna have stuff in here. So p move. Now when I call this one, so I'm pressing the arrow keys and our character is moving. When I press the W and S keys, again our player is moving. Now the next thing we want to do is we want to add boundary checks. We don't want it to, move off screen like that. We want it to, when it comes here, it stops, and also when it comes here, it stops. So here we'll be checking if these keys are pressed, and we'll also add another condition. So if these keys are pressed, and now we're checking when we're moving upwards, if the top of the image rect top. So the rectangle is this self rect is the rectangle around the image, and if the top of the image is greater than 0, so if the top of the image is greater than 0, it is not outside of the screen. But if it gets less than 0, it means it's moving, it's starting to move outside of the game screen. And here is the same thing. And self bottom is less than window height. So if the bottom of the image is smaller than the window height, it's inside of the boundaries. Otherwise, we're not going to be moving it. So let's check it out. And I'm pressing the up key, but it just stays there. And here it should be self dot the rectangle. The bottom of the rectangle of the image should be less than window height. So moving up, I cannot move more than that. Moving down, I cannot move more than that. So okay, we have boundaries around this image. Now, one thing, this player class, we also have another function called update. And actually, all that update will be doing is called this move. And so we're not going to be calling the move function, we'll be calling the update function that calls the move function. So if I put update here, we'll see the game will work as expected. Now, this update function is actually part of the sprite class. And we are in a way overwriting it, and we're telling it how our player should move. And anytime we inherit from a sprite class, we get a couple of functions like the update function and also the draw function. And we'll see these functions a little bit later, and they are very helpful because they take care of all the interaction of the image. So this is a best practice, to put all the logic of moving the sprite inside of the update function and the drawing of the sprite inside of the draw function. Okay, now I'm gonna remove these ones here. I'll actually remove all of these. So inside of my while loop, I'll have just the event loop and also the update command and the tick command. And before we move any further, I also want to add an option that we can quit the game by pressing the escape key. Because sometimes we don't close the program from the close button, but also when we press the escape key. That's especially true for games. So, and we'll add this in the event loop. So we'll be listening for the key down event. So if a key is pressed, so here we're saying if a key is pressed and the key that is pressed is escape, we'll do the same thing. We'll set running equals to false, which will exit the while loop. Now when I run the program and I press the escape key, Pygame has no and that's of course is key underscore escape. just like these ones, key down, key up. So I press the escape key and the game closes. Now, again, I'm gonna remove this one because this is just for testing purposes to see if everything is working fine with the player. So this is pretty much our player class. You see, we initialize the player class by giving it a type, and depending if it's a boy or a girl, we're loading the respective image. Then we scale the image because it's a little bit too big, and then we add a rectangle around the image. We get its position coordinates, and then we set its velocity. So how much we'll be moving it. So 10 is it's an okay to move it by 10, and we have a move function that says how we want to move the sprite on the screen. And in this case, we're just going to move it vertically, up and down. And we'll be calling this move function inside of the update function. So this is pretty much our player class. Now, a little bit later, we'll be adding the food item class. But before that, I want to start working on the game. Because the game class will take care of stuff like collisions between the player and the food objects. It will take care of the scoring system, how many lives we're left, and it will also take care of which screen to show. Now, if you remember in the beginning, we had three screens: the initial screen where we can choose the player, the play screen where we're actually playing the game, and the end screen where it shows us the final score, and also it tells us if you want to play again. So with that being said, I'm going to create the game class here. Now, the game class, unlike the player class, will not inherit from the sprite class, because the game class is not a sprite. The game class is just a regular Python class that will handle interactions between the other classes and scoring system and stuff like that. So this game class, it will not inherit from anything. This is a regular Python class. So again, it will have a init function. Now, when we initialize our game class, it will not accept any parameters. We'll just initialize it, and the class will be doing what it's doing inside of itself. Like, all the internal logic of this class will be inside. It doesn't depend on outside parameters like the player class. It needs to know what type of player we're creating. So the game class will contain a couple of class variables. Now it will have a player class, and we'll set it equal to none, because in the beginning, when you create the game, we don't know what kind of player will be working inside of the game. Is it a boy player or a girl player? So if we didn't have that initial screen where we can choose the boy or the girl, we can just call the player in here. We can pass the player here in the initializing in the initialize method. But since we don't know what kind of player we'll be using, we'll just set it currently as none, because we don't know. We also have some stat variables. Now we'll start with 5 lives, but just for testing purposes, I'll make them 1 currently. And when the game is working, we'll add the 5 lives. We also have the score, which in the beginning will be 0. And every time we catch a healthy food, we'll increase it by 1. And every time we eat junk food, we'll decrease it by 0.5. Now, our game will have three states. The start state, where we can choose the player, the play state, where we're playing the game, and the end state, where we show the final score and where we prompt the user if they want to play. And when we initialize the game, we want the self state to be equal to start. Now, I'll make a comment here. Here we'll load also the background music and also the... Actually, we can do them right here. We're not gonna play them. We're just gonna load the music. And that's when sounds. Now, by default, this background music is a little bit too loud, so I'll set the volume to 0.1. And we'll also load the eating sound. Okay, that's a waff sound. Now for the background music, we don't need to add it to a variable. We just load it as it is, and when we call Pygame mixer music play, we can play it. Now for this sound, we want to play it on collisions. So we create a class variable, because in other methods inside of the game class will be calling it. So here we're just loading the sound inside of the initialize method. So when we create a game variable, these resources will be loaded, and we'll have access to them in other methods of the game class. Now I'm gonna have a update method. And inside of the update method, I'll be calling different functions. And currently, let me put this pass here. So let me actually create the game class here. I'll call it my game. So here I'm initializing the game, and let me see if everything is working correctly. Okay, we don't have any errors in the console, so I know everything is working as expected. And believe it or not, guys, but inside of the while loop, the only thing we'll be calling in here is my game update, mygame.update. So inside of the update method will be the logic. The game will be taking care of all the logic inside of here. So when we start the game, we want to first make sure, we want to check for the states here, because we'll have 3 states, and for each state we'll be calling different methods in here. So when we initialize the game, our state will be set to start. So start will show the start screen. So in here I'm going to be checking for, I'll be checking the state. Now if the state is set to start, I want to do something. And what I want to do here is I want to show the start screen. So, and we're gonna write this method right now. Show init screen. So when the game starts, show the initial screen. And I'm gonna write that method right now. This method will not accept any parameters. It will just show the stuff, the stuff on the screen. Now the initial screen, will have a little bit of text, and it will also have the images of the boy and the girl, and it will also have a way to choose either one. Now here oh, wait a minute, we didn't load our yeah, we need to load our fonts before we can use the text. So under the background image I will load my font. We have only one font, but we'll create two fonts out of it. We'll have one for the title font and for the content font. So the title font, we'll use this font, and it will be 85 pixel in size. And we'll also have another font. Now the smaller font will be used for the content. So this is just for the title, and for the other ones we'll be using the font content. So for the initialize screen, we want to start loading the texts. So for the title text we'll be using the font title. And we'll just print the name of the game. Now this will be anti-aliasing will be true. And for the color we'll use yellow. Now just like images, we can also add rectangles around the text here. And when we add rectangles we can better position them on the screen. And for all of them they'll be in the center, pretty much. So I want to be like the middle on the horizontal axis and a little bit to the top. So this thing we'll place it in the middle of the screen, and then I will move it up, because on the y-axis when we move up we decrease the y coordinate. So it'll be 200 from the center, move up. I want the title text to be in the top. a little bit higher. Okay, actually, okay, so we can see better. And okay, so underneath the title text, we'll have the info text, and I'll be using the content font content. So -100, it will be a little bit under the title text. Now under the info text, we'll be prompting the user to choose a player. And this will be smack in the middle. So this will be in the middle on the vertical and the horizontal axis. This will be above it, -100, and this will be above this one, -200. Actually, let me show if these things are appearing before we move any further. Show initial screen. Yeah, they're not appearing because we are not adding them to the screen right now. Let me just draw them on the screen. Now by default we'll fill the screen with black, and then we'll fill the background image. So I guess we can also put these ones. Are we? Yeah, actually I'm gonna move these ones, guys. Oh no, I'm gonna leave them here. Okay, so we are filling the screen with black, and then we are blitting the background image. And there we have it. Now we need to blit the title text, info text, and the choose text. And there we have them. We are blitting the text. Now underneath the choose your player, we need to put the two images of the boy and the girl. Now the images for the boy and the girl, we'll be using them a little bit later, so I'll make them I will make them class variables. Now, in order to place the boy image and the girl image, I want them to be side by side, but I want it to be kind of centered on the horizontal axis. So what I'm gonna do is I will take the middle of the left. So let me so if this is the image, this is the middle left. I want to take this coordinate and get this dimension, draw the image, and then when I get the girl image, the girl image, I want to have the mid right and move it from the right margin, so that they are centered in the image on the screen. So I want it to be from the left 300 pixels, and then window height divided by 2, and this time plus, because it needs to be under the choose text, plus, let's say 100. Now for the girl, I'm gonna get the mid right, and I want to move it 300 pixels from the right. And on the vertical coordinate, again it will be 100. So let me just show them. Okay, I need to close this another parenthesis. Oh, I'm sorry. 300 is from the... I wanted 300 from the right border, so this border. In order to get it 300 from that border, I need to get the window width minus 300. So they're in the center. So there's 300 pixels from here, from the right border, and 300 pixels from the left border. So they're in the center. Now the next thing I want to do is I want to add a border around each image, so they are better visible. So when we're drawing rectangles or borders, we pass the screen, the color, the rectangle around which we want to make a border, and the thickness. So there is a white border around this image. And I'm going to do the same for the girl image. Now, the next thing I want to do is when I hover the mouse over any of these images, I want the border to turn yellow, so that makes it visible that which image we want to select. And then we'll be listening for the click event. But currently, what I want to do is just add a hover effect so that this white border becomes yellow. Now, in order to find out if the mouse pointer is over an image, we can use the following condition. Now, if the rectangle of this image collides, any of its points collide with the mouse positions, in order to get the position of the cursor, we use Pygame mouse get pos. Let's print hover over boy. So if I run this thing, and when I hover over the boy, we're getting this text here. So every time we're hovering over the boy, we get the text. So when I'm hovering over the boy, I wanna change the color of the border to yellow. Else, so if the mouse cursor is over the rectangle of the boy image, draw a 2-pixel yellow border around it. Otherwise, just draw a white border. And here, when I'm hovering, you can see that the border changes. So that's good. And I want to do the same thing for the girl. Oh, I'm sorry, not this one. Else, and let me actually move this one here. So there we have it. We have the hover effect over these two images. Okay, so the next thing we need to do is we need to detect when we click on one of these images. So inside of the update function, Before we check for the state, I'll be calling another function that will be listening for user inputs. So I'll call it user input, and this function, depending on the state, will be listening for different events. So in the start screen, in the start state of the game, we'll be listening only for the clicking of the mouse. So when I click the girl or the boy image, this is the only thing I'll be listening. So I'll create a function down here. Now this function will be called every time we update the game. So depending on the states, it will use different, it will be listening for different events. So if the state is start, I need to be listening for the for when the mouse is clicked. Now, in order to listen for the mouse click, we need to get the following condition. Now, when the mouse button is down, now let's see what this is going to get. So currently I'm listening for the mouse button down. So if I click here, I'll get 1. And the reason why I'm getting 1 in here is because I click the left mouse button. If I click the right mouse button, I get 3. And if I click the middle wheel between the two buttons, I get 2. So I want to listen only for the left mouse button. So when I'm clicking the left mouse button, that means 1. So if this is the mouse button is down and event button is 1, so here I'm listening only for the left mouse button. But this is still not complete, because I don't want to listen. I want to detect a click on the image, not when I'm clicking, for example, on the text or on the background, only for when I'm clicking on the boy or the girl. Now, when I click the boy or the girl, I'm pretty much selecting my player. So I need to set the player, and before I do that, I'm going to create a player type, and in the beginning it will be equal to none, and I need to detect what is the player type. Is it a boy or the girl? And then I'm going to pass that variable to the player, because the player accepts a type of player, a boy or a girl. So first of all, I need to check if I'm clicking on the boy. If I'm clicking on the boy with the mouse. So I can use this same thing. If the boy is clicked, I'm gonna set the player type equals to boy. So if I click the boy, I set the player type to boy. If I click the girl, I set the player type to girl. And then in here, I will check if there is a player type. So if this is different from none, I need to create my player. So I'm instantiating from the player class an object called player, and this player type will either contain boy or a girl. Now, I don't think I mentioned this thing, but anytime you have a class that instantiates from, that extends, not extends, but inherits from the sprite class, you cannot add these classes. When you instantiate that class, you cannot add it directly to the screen. This sprite class acts in such a way that in order to add an object that inherits from the sprite class, you need to add it to a group before you can add it to the screen. So if I create a player, here we're creating this player, I cannot add it to the screen. I need to add the player to a group and then add it to the screen. So only the group can be added to the screen. It's just the way it is. You cannot add it as it is. It needs to be part of a group. So I'm going to create a player group, and I'm going to create the player group in here. So create a class variable because I need to access it outside of the user input method. Now, Pygame offers us two types of groups. One is just group, where we can add multiple objects, and we also have the group single, hold on a second, guys. Okay, so my bad. Yeah, we're creating this player group, but we'll be creating the groups later. So we're creating right now the player group, and we'll be adding this player here. Now the next thing also we need to do is we need to set the player, because this player currently is the we just created in order to add it to the group, but we also need to set this player, and I'm gonna create a separate function, or actually not. So the player, the class variable player, will be equal to player. Okay, hope that didn't become too confusing, but pretty much when we click the boy or the girl, we get the type of the image that is clicked, and then we create a player variable with this type, and we add that player to a group. as I said, we need to add them to a group before we can use them in order to show them on the screen. And then we set the player to this player. And last thing, we need to set the state to play, because here we're in the start state, but once we click one of the images, we need to change the game state to play. And inside of the update function, I need to write another condition, elif self state equal to play. And let's check if we enter this state by calling a Pygame function. And inside of Pygame, let's just clear the screen and just show the background image. Okay. So we can hover over the image, but once I select one of the images, game object, okay. So here when we create a player, as I said, each player needs to belong to a group. And I'm going to create that player group here, and I'll assign it to Pygame sprite.group single. Now we're creating this player group that will hold the player, and because we have only one group, one player, we'll create a group single. Group single will have only one object. So here when we create this player, we assign it to this group, and now we have it. So a little bit later, when we're creating the food items, we'll be using just the group, the sprite group, because we can have multiple objects inside of the group. But because the player is just a single one, just one player, we'll add it to a group single. And a little bit later, we'll do it the same for the food items. So we need to have a player, we need to add it to a group in order to show it to the screen. Okay, so let's run it again. Okay, and this is working. So when I select one of the players, we enter the game, the state of the game changes to play. We clear the screen. So when we click one of the boy or the girl, we create the player, we change the state to play, and then update skips this condition and executes this condition. So we're inside of the play state, and here in the play state we need to add the logic for playing the game. So inside of the play game, first of all, I need to show the player. Like I said, we show actually the group that contains the player. We cannot show the player as is. We need to show the group that contains the player. So this draw function comes from the sprite class that we inherited. The update also comes from the sprite class. So let's see if this player will appear. Okay, the player appears, and I can move it with the arrow keys. Okay, so we're showing the player. Now the next thing we need to do is also show the food items. And before we move to the food items, first of all we need to load all these images, or not load them, but just get the names of each food item. So here, before it's not going to be inside of a class, we'll just add them. Let me just add some comments here, guys. So this will be colors, background image, fonts, initialize game, and here I'm gonna get the names of the foods. Now I want pretty much two arrays. So the first array will contain apple.png, banana.png, blueberries.png, etc. So I want to get all of these, but I'm not going to be writing them. I will just use this OS module that is part of Python to get the file names. So the first one will be the healthy food. And we'll be using list comprehensions. So let's actually print these ones. So what we're doing here is we're iterating over all the files inside of this directory, images/healthy, and that is if. And if and we're getting the path, the name of the file. So we're getting the name of the file and we're returning it. And it will save it as just the file name. So we're getting the file names from each file inside of this directory. And there we have them: apple, banana. Yeah, these are all. And then we're gonna do the same for the junk food. And let me just print them to see that we get it. Okay, and here the junk foods. Okay. So now when we have this names of the images, I'm going to create the food item class. And just like the player class, it will inherit from the sprite class, because this class will show images on the screen. And again, it needs to call the sprite class initializer. So super refers to the sprite class, and this will get all the functionality from the sprite class inside of the food item. So food item will receive methods such as draw, update, and some other methods. And we can choose to override them or just leave them as they are. Now when we're creating a food item, just like the player had a type. It's either a boy or a girl, and we want each food item, when we create them, to also have a type. The type here will be either healthy or junk. Now, depending on the type, we need to get an image from the array of names that we just created. Now we're gonna load, I need to load a random image from the healthy. So if I pass healthy as a type for food item, I want to get a random image from these ones. I don't want to get the first and then the second, just pick a random one. So sometimes it will pick, for example, the pair and then pick it again. So maybe we can have two pairs that are flying at us. So in order to do that, we need to get the path to the image. And this will be healthy. So healthy. And now we need to get from this healthy food, which is an array. We want to get a random item from it. Now I'm going to use the random module, choice, and choice choice accepts an array and then picks a random item from this array. Healthy food. Now, if the type is junk, and here I'll select item, random item from the junk foods. Now once I have either a healthy food, a random healthy or random junk food, I need to assign it to its own image. And of course I need to create a rectangle around this image. Okay, so now I need to give it a position. So this image needs to be positioned. And what I want to do is, I don't want them all to start from the same place. I want some of them to start a little bit further from the right border. So when I generate these images, I don't want them to start to be visible. I want it to be outside of the border. So if this is the game window, I want to generate them over here. So if this is the game window, and I want to generate one here, maybe one here, maybe one here. So I don't want them to be generated on the right border. I want them to be outside of the right border on some random principle. So the Y, actually the X axis, and I want them to be here on the X-axis randomly, but also on the Y-axis they also need to be randomly. So somebody might start from the top, others at the center. So this random randint will generate a random number between window width and window width plus 20. So window width is the right border. Window width plus 20 is, it will add 20 pixels to the right border, and it will generate somewhere in here. Now on the y-axis, this will be the vertical axis. It will either start from 0, from the top, or window height minus 64. Now because each of these food item images will be 64 pixels, I want them to be not here at the very bottom, but 65 pixels at least, so that the image is not generated half of it visible and half of it under the bottom border. So I don't want the window height, but the window height minus 64, which is the size of the food item. And last but not least, I want each food item to have a velocity, and I want the velocity also to be a random integer. So 3 will be slow, 13 will be the fastest one. So some will move slowly, some will move fast. And you can change these values, you can experiment and see what's going on with them. Now, just like with the player, we want to have a move function. And actually we're not having a move function because we're not moving these images. We have an update function, and all that update will be doing for each food item that we generate is we want to move them from from right to left. So they'll be moving on the x-axis, because x-axis is the horizontal one, and when we are moving to the left, we are decreasing the x value. So when we're moving these ones, they will be moving to the left with the assigned velocity. If the velocity is 3, they'll move slowly. If it's 5, they'll move kinda okay, and 13 will be the fast ones. So they'll always be generating somewhere over here, and then they'll move to the left. Now, the last thing we want to do here is create a destroy function and our game class will be taking care of what happens with these food items when they leave from here, from the left border, or when they collide with the player, because we'll have different functionality for both of these situations. So I'm going to create a method destroy that will destroy the image if it leaves this left border, or if it collides with the player. Actually, I'm going to create a logic just when it leaves the border, the left border. Now this kill function is part of the sprite. It comes from the sprite, and it will kill the sprite, meaning it will remove it from memory. When an image, the x of the image, so when the image reaches this border, I want to remove it, so it doesn't keep the memory that it is assigned. And we will see a little bit later how we use this destroy function. And I believe the sprite class is, the food item class is ready. You know, just like with the player, we're passing the type, which is healthy or junk. It will get a random healthy or junk image, load it, make a rectangle around the image, assign a x and y coordinate, random x and y coordinates, assign a random velocity, and then we're updating it just by moving it to the left. So we're updating just the x coordinate, we're moving them to the left. And then we have this destroy method that we'll call a little bit later when they reach the end. Now the next thing I want to do is code the logic for the interaction between the actually for generating the images. Let's first generate the food items, and then we'll work on the collision. So in order to generate them, I need again to have a group for the food items, and inside of the game I'll create a group for the food items. Now here I'm going to use the group because the food items will be more than one. If I have only one from a single class, I'll use the group single, like the player, because I have only one player. But if I have more than one items, I can use the group class. Now in order to generate the food items and assign them to the food items group, I'm going to create a timer. Now Pygame offers us the ability to create timers that will be called on a specific time interval. So you can create a timer that will be called, for example, once per second, or that will be called once per 10 minutes or something like that. And I will write this timer in here, not inside of a class but outside. Now this timer will be taking care to generate a random food item image. So in order to create a timer, we use the user event, and then we add 1. So if you have a second timer, you'll create it pygame.userEvent plus 2. If you have a third timer, it will be pygame user event plus 3. Just you need to add this one. So because we have only one timer, we add plus 1. But if I had other timers, I will add 2 for the second timer, 3 for the third timer, etc. And then we need to set the timer. And when we set the timer, we want to set which timer. So I want to set this timer. And the second parameter is the interval in milliseconds. So 1 second has 100 milliseconds. And what I want to do is I want every second and a half to call this timer. So every second and a half I want to generate a new food item, and then keep on generating them like that, so using that timer. Now in order to call this timer, here where I have my loop, event loop, inside of the event loop I want to check, I want to call this timer, but I don't want to call this timer when the game starts. I want to call this timer when the game state, this game state is set to play. So if the game state is set to play, I want to call this timer, which will start generating food items. So here I will check the game state. If my game state is play, that means I have selected a player. I need to start generating the food items. If this state is set to play, and I need to check the type, just like here. So if and we need to check if the event type is the food item timer, because we can have other timers, but since we have only one, we need to check if this timer is set, if this timer is ready. Now what I want to do, and what I want to do is I want to add a food item to this food items group. And I'm gonna do this using a function. So inside of my game, I'll write this function, but let me just add it here. My game add food item, and food item will accept a food item. So this is the class that we already created, and if you remember, guys, food items accept a type. The type will be either healthy or junk. So I need to randomly pick a junk or a healthy type, and then the initialize method will generate the, depending whether it gets healthy or junk, it will generate an image. It will load an image. So I'll use the random and again choice, and choice accepts an array or a list, and I'll pass healthy or junk. So when this timer is active and the state is set to play, I'm gonna add a food item, a random food item with a type healthy or junk to my food item group inside of the game object. So let me actually do it here before the update function. Add food item, so this food item is this function that we are calling when the timer is active, and we are passing a food item with healthy or junk. And all we need to do here is add to the food items group. And I know we can directly code it in here, but I just want to make it more obvious like that. And actually we wrote a lot of stuff, and I hope this works. Okay, we have a 39. So when I pick a player, and nothing is happening, we don't have errors, and I believe so here when we're playing the game, remember guys, the fact that we created the food items doesn't mean that they are printed. They're part of the group, but we need to draw and update that group. So food items group draw on the screen and then update them. And there we have it. We have items are being generated, random items are being generated. Some are healthy, some are junk, some move slower, some move faster. Right now there is no collision, so when they collide nothing happens. But the moment this and currently when these move over the left border, they keep on, they're still in memory. We haven't coded also that logic. But the good thing is that the timer is working. It is generating food items every second and a half. Now here in the update function of the game class, when we're playing the game, we also want to check for collisions. So when the player collides with one of the food items, we want something to happen. So I'm gonna call a function called check collisions, and let me actually write it underneath it. Now, when I collide with an item, I want to know what type of item I collide with. Because if I collide with a healthy item, I want to increase the score. But if I collide with a junk item, I want to decrease the score. So how can I get the item that I collided with? And Python has us covered here, because there is a function that gives us that information. So I'll create a variable here, collided food item. So sprite collide any. Now this function accepts two parameters. What is collided with what? So the collided item, the collided food item, will tell us which item from this group collided with our player. So when the player collides with one of these groups, I want to get this item. And let's see what this will give us. So none, none, but when I collide with this one, okay, it's printing them really fast, but you can see the sprite. And let me actually get each sprite, each food item has a type, which will be either true or healthy. So let's print this one, the type. Isn't it code type? Food item. Items group collided. Oh, okay. So in the beginning, this will be none because nothing is collided. So let me actually. So if collided food item, because in the beginning nothing will be collided, so this will be none, and I cannot call none on type. So then I'm gonna print it. So if I collide with the pear, it gives us healthy. The cake, junk. The strawberry, healthy. The cake, junk. These are healthy, healthy, healthy. This will be junk. Okay, so I'm getting the correct sprite. Okay. Actually, let me save this one. So if the type of the collided food is healthy, I want to increase the score with 1. Else, now if it's not healthy, it will be junk. It's either healthy or junk. Now I want to decrease the score with 0.5, but if my score is 0 and I collide with a junk food, it will become negative. The score will become negative, and I don't want to have a negative score. If it's 0, I want it to stay 0. So if the score is greater than or equal than 0.5, only then do I want the score to decrease. So if it's 0, I don't want it to decrease. I don't want a negative score. Now the last thing I want to do is, inside of the collision, remove collided item. So the food item that collided with the player, I want to remove it from the group. Otherwise it will just hog memory. So the collided food item, we remove it and we pass from which group. And I have only one group, so I remove it from the group with all the other items. So if they collide, I want to remove them. Okay, this is for items that collide with the player. But what happens with items that do not collide? Now, if they're junk items, I don't care about them. Actually, I care about them, because if they move from the left border, I want to kill them, I want to destroy them. But also, if they're healthy items, I want to decrease the lives. I'm losing a life if I miss a healthy item. So here inside of the play state, besides checking collision, I also wanna check for missed items. Or missed food. If I miss a food, I wanna check if it's healthy or if it's junk. And I'll just maybe right over here. Now, the missed food, I didn't collide with it, so there's gotta be some way to find out if a food item from the food group has left the screen. And the only way I can do that is to make a for loop that iterates over all the food items inside of the group. So I'll go over each item and check the x coordinate. Or check the right border. So if the right side of the image, so this is the right side, if the right side image is less than 0, that means it passed this border. And the type is healthy. I want to decrease the lives. I want to remove one from my lives. And then I want to destroy it. So if the food item leaves the screen from the left side, I'll decrease the lives and destroy it, so it doesn't occupy memory. Now the last thing I want to do inside of this condition is check for the lives, because I don't want to have negative lives. If I reach 0, I need to do something. Equals to 0. it's less than or equal to 0. I want to change the state to end. So when the lives are less than 0, the game state will change from play to end, and I'm gonna show the end screen. Now, before we work on the end screen, here when we're playing the game, I also want to show the lives and the score on the screen. And I'll call them update state. Now, for the update, the state will have just two texts, the score and the lives text. And we'll just bring them to the screen. That's all we're doing. So for the score text, I want to add a padding in the beginning and at the end, so it's not right next to the border. It will be orange text on a white background, so it's visible. I'll place them in the center. So this will be horizontally centered, and vertically from the top it will be 20. So the score will be up there, and the lives will be down there, down at the bottom. So score will be 10, 20 from the top, lives will be 20 from the bottom. And all I need to do is just bleed them or show them on the screen. And this should be lives rect. Okay, let's see what's going on here. Okay, I've got the score. So see when the score is 0. Okay, it's 1, 2. Okay, it's working properly. Junk food take 0.5. Now if I miss, lives get 0 and the game stops. Now when the game ends, I wanna do something here. So if the game ends, well, I want to show the end screen, let's say so. Now, the end screen should show the background. So it shows the background and a couple of texts. First of all, we'll show the score text. And also we want to prompt the user if they want to play again. And it will be yellow just to make a contrast from the score text. And we'll put it 40 pixels from the score text. And of course I need to split those texts. Okay, let's see if this is working now. And I keep forgetting the closing parenthesis here. Okay, so when I miss this one, the game stops, it shows the score, and press space. Now currently when I press space nothing happens because we didn't code this logic. And of course we're gonna place the logic inside of the here in the update function we're calling this self user input, where we're listening for inputs. And in the user input we have, for this state, for the start state, we're listening for these events, but underneath it I'll say if self state equals to end, I need to listen for the space key, because here this is the only key I'm listening for. So if there's a key pressed and the key is a space. Now we need to start the game, so of course I need to change the state of the game to start, and I wanna reset the variables. So lives will be equal to 1. This is just for testing. We'll later change it to 5 if I don't forget. Self score will be equal to 0. Now the food items group, there'll be like stuff in it, so I need to clear it, empty. Okay, and let's try it out now. So I get 1 score, 1.5, and let's end the game here. Press space, and again score is 0, lives is 1, 2, 3, let's make it 2.5, and let's die now. Play again. Okay, so this is working. Now the last thing I wanna do is add the music. Let me see. So the eat sound, we wanna play the eat sound when I collide with an item. So collision, if food item collided, play the eat sound dot play. Okay, let's check it out. Okay, you can hear it, I hope. Okay, and the last one is to add the background music. And we want to add the background music where we start the game. So this show init screen. No, it's in the user input. So here we're starting the game. Now, when we have this music, we can pass the parameter -1. -1 will loop the music, the track that's being played. If we pass 1, it will play it once. If I press twice, 2, it will play it twice. But if I pass -1, it will loop. So when it stops, it will start playing again. And when we end the game, I'm gonna stop the music. Stop. Okay, let's try this one now with the music. And of course we need to avoid the junk food. And the music stops when the game ends, and it starts again when I start the game. Okay, so that's pretty much it, guys. The game at this point is playable, And as you see, we put a lot of the logic inside of the classes. The game class is like it combines the food item and the player class. It checks for collisions between the two classes. It takes care of the game state. It also takes care of the lives and the score systems. So it's doing a lot of stuff. And as you see, our game loop is very short. We pretty much have the event loop. We call the update, which takes care of all the states. And that's pretty much the game. So I hope you guys enjoy the game, and I'll see you in the next tutorial.